Hi, this is Sean Chua. Welcome back to simplecemconcepts.com. Now, in the previous videos, I've discussed how the position of ions in the metal reactivity series, as well as the concentration of the electrolyte solutions, affect the selective or preferential discharge of ions in electrolysis of electrolytic cells. Now, today I'm going to talk about the third factor, which is the nature of electrodes and how it affects the selective discharge of ions, right? Now let's take a look at the board. This is always the diagram that I show my students in my Sec 4 O-level pure chemistry tuition classes for the last 19 years. I wanted to put them side by side, one after another, so that you can see the effect very clearly, alright? So once again, there are two types of electrodes. One is called inert, one is called reactive. Who are your inert electrodes? We are talking about the common two, which is platinum, the metal, or carbon in the form of graphite. Alright, in the form of graphite. Okay, so these are your inert electrodes. Then what are reactive electrodes? Will be the rest of the metals that you can see from the metals reactivity series, all the way from potassium to even gold. Even gold, so-called non-reactive metal or unreactive metal, when it comes to being an electrode, we will say it is a reactive electrode. Alright, so that's something that you must take note. Gold is considered a reactive electrode. Let's come back to the board. Alright, now let's work out the cells first. So this positive, negative, positive, negative. Similarly for this side as in the form of electrolytic cells. If you miss out all this because this is the first time you look at this video, then please go and watch my other videos, the earlier videos I was saying, to have a recap of all the basic concepts. Alright, so the electron will travel down here, go back there, electron travel down here, go back there, and then what are the electrodes and electrolyte? So this will be, let's choose platinum, alright, as the inner electrode. So here maybe we choose copper, alright, as a reactive electrode, and then the electrolyte I'm going to choose the same one so you don't see the effect, alright. So it's copper 2 sulfate solution. If you still remember what I discussed in the previous videos, especially the one on basic concepts of electrolytic cells, I mentioned that we should, first step, write down all the ions that is present in the electrolyte. So in this case, it's CO2 plus, SO4 2 minus, H plus from the partial dissociation of water. Same for here, you're going to have the same ions. Alright, I'm not writing the state symbol, you should know all of them are equals right now. So what happened is this, okay? So when the electrodes are inert, it's going to be very easy. It's all based on the other factor we discussed called the position of so-called the ions in the reactivity series, alright? So negative charge ions, alright, negative charge electrode will attract the positive ions, the cation ions. So you got H plus, CO2 plus. CO2 plus has a higher ease of discharge, so it will swim over here, get attracted, and take in the electrons to get reduced and to be selectively discharged over H plus ions. So at this side, you're going to have CO2 plus, in terms of equation, you take electron and it becomes copper solid. So what you see over here is a layer of copper, alright, that will be deposited. Copper metal. Okay, so what about the other side? This side is positive charge, so the negative ions will go there, sulfate and hydroxide. Sulfate, as we mentioned previously, will never get discharged, so it will be your hydroxide, and 4214. So this side will be 4, alright, 214. Something to memorize so they can move a lot faster. Okay, all my students know about this, alright? So what do you see? You're going to see bubbling, right? Or you see effervescence. Okay, obviously the oxygen gas will escape, but oxygen is colorless, you can't see. So you see effervescence around here in the electrolyte solution. So over here there will be increase in the mass of the electrode this side, which is your cathode. Okay, so what do you see? Number one, cathode will increase in size or mass, and you will see a layer of pinkish or reddish brown. either color is fine, alright, of copper solid deposited. So this is what you saw or you see at this side called the cathode. What about the anode? Alright, at the anode, you will see effervescence due to O2 produced. Okay, so this is the observation. Now, a lot of time in exam they also ask you what happened to the electrolyte solution towards the end of the reaction. So what do you observe over here at the end of the electrolytic process? So if you take a look once again, these two ions are getting lesser and lesser, right? They are being selectively discharged. Your copper is getting lesser and your hydroxide ion is getting lesser. So what happened is you have more H plus than hydroxide ion. So number one, you're going to have an acidic solution. In fact, you even know what is the acid. It's sulfuric acid. You combine the two ions together. H2SO4 is due to this acid form. Alright, or you can say that H plus ions is more than hydroxide ions. That's one. Second is copper 2 plus ion is blue in color, and this gives copper 2 sulfate the blue color solution. Alright, or it gives the solution blue color. So as copper 2 plus selectively discharged, getting lesser and lesser, you will see that the blue solution will become pale, more pale or paler. Alright, become more pale or more less blue. Alright, so that's what you see. Now, what about the other side when we talk about your reactive electrode, let's say copper? At this side, which is at the cathode, is exactly the same. Alright, so what happened is copper 2 plus ions will plus 2 electrons. Maybe I'll stand over this side so there's not to block you. Alright, this will form copper solid. So what you have once again is this layer, okay, at the cathode side, because the cation ions with copper 2 plus H plus will be there. Copper 2 plus once again more has high ease of discharge, will be preferentially discharged over H plus. So this is the same. So at the cathode, what do you see? You're going to see exactly what we wrote just now: increase in size and mass. And what else do you see? You also see a layer of pinkish, alright, or reddish brown copper solid deposited there. Now, is at the other side, which is at the anode, you need to be very careful. Now, at the anode, by right, like what we did over here, right, it should be your hydroxide ion that gets discharged, because it has high ease of discharge than sulfate ions. By right, it's 4214. Hydroxide ions form oxygen gas, you see effervescence. However, do note at this side there's something special, because copper is a reactive electrode. Copper itself, copper metal, will also tend to want to get oxidized at the anode. So what happened over here is this step is more predominant, it is more preferred over the discharge of hydroxide ions. So over here, the half equation will then be copper solid oxidizes to become the copper 2 ions, and 2 electrons are given out, which goes back to the battery. Alright, so what do you observe over at this end? You're going to see that there's a decrease in the size and mass of the anode. It becomes smaller and smaller. Right? Let me redraw this a bit. So it becomes smaller and smaller. So what really happened is the copper has become copper 2 plus. It oxidized at this side of the anode, and then it gets back on the cathode. In the net reaction, alright, from the start to the end, if you consider this, then you will be able to answer the last part, which a lot of students find it tricky, which is at the end, what happened to the electrolyte solution. Now, if you take a look, what really happened is, in the net reaction, the copper 2 plus that was so-called discharged at the cathode actually did not come from the electrolyte solution. Right? It comes from the anode. Right? It's a transfer from here to here. So what happens to all the electrolyte ions, or the ions in the electrolyte? Nothing happened at all. So the blue color solution remains, and there's no change in the concentration of it, which is the solution, as well no change in concentration of solution, as well as the pH of the electrolyte. Everything stays the same. Alright, so take a look once again. There's really a big difference in terms of the reaction at the anode. Okay, when you have a reactive electrode at the anode, you have to be very careful. Okay, so once again, I've come to the end of my video. I hope you enjoy yourself. Feel free to share my videos with all your friends who need help in chemistry, especially electrolysis topic, which a lot of people find tough and challenging. Okay, once again, signing off. This is Sean Chua from simplecemconcepts.com, and I look forward to seeing you in the next video. Bye bye.